Okay, so looking at these diagrams, we're going to look at the anorthite and diopside system. Now, as we looked before, it is a eutectic system. What that means is we've got two minerals in there. Okay, so we're looking at the calcium-rich plagioclase feldspar called anorthite. So that's on this side. And we've also got the pyroxene mineral diopside. So we're looking at a calcium-rich plagioclase feldspar and a pyroxene. So we're actually looking at something that's fairly high up on bone reaction series. And you can tell that from the temperatures we've got here. We've got high temperature minerals. So we're looking at things that will crystallize out first from a melt. Now, we have this eutectic system with two different lines for the liquidus, point at which the melt turns into crystals, because we've got two separate minerals which they can't mix together. So they actually have to stay separate. What we will look at is we've got the scale running from 100% anorthite on this side to 0% anorthite on this side. And then obviously this side we're looking at 100% diopside. Okay, so just put an extra annotation there. We're looking at the mass of anorthite. Okay, so let's take a melt which has got 70% anorthite. Draw it very crudely on there. So as the temperature drops, and we're starting at 1700 degrees Celsius here, as the temperature drops, we'll get towards that point of crystallization. Now, if we had a 100% anorthite, then it would start to crystallize at 1557 Celsius. That's the actual crystallization point of anorthite. That's why that is highlighted there. But we're talking about mixed systems, so we don't always have a pure mineral. We've got 70% anorthite. Let's put that on there. That cools down, that starts to crystallize there. So what happens is some of the anorthite starts to crystallize. So what we have here is we're looking at a mixture of anorthite crystals and remaining liquid. Now what happens is, because the anorthite is crystallizing, the liquid becomes depleted in anorthite. So that's why we follow this liquidus here. And as it gets depleted, you see the percentage of anorthite less and less. It gradually becomes more and more depleted, let's say at 1400 degrees Celsius there. We'll read off, we've got just over 50% anorthite, and that's in our liquid. Obviously, because some of those crystals, those anorthite crystals, are now in that crystal system there. Now, continues to cool down, we'll get to that point at which all of the liquid and both solids can exist. But once the temperature drops further, it will crystallize out completely. And then essentially it goes back to this point here. And we have 70% anorthite again. Now you can do the same on the other side. If you're looking at, say, 30% diopside, sorry, 30% anorthite, and a higher proportion of diopside, then the diopside will be the first mineral to crystallize. As that crystallizes out, it becomes depleted, and we follow the liquidus in that direction. The diopside is depleted, becomes crystals in there. We get a higher percentage of anorthite, and here at the point, the eutectic point, we're looking at about 4% anorthite, 16%. We get total crystallization. We go back to 30% anorthite, 70% diopside. Slightly off just because of my crude drawing by hand, but hopefully that explains it.